when we look at a function like this, we first look inside and think about what the input of this function would be. So we know that sine of a reference angle will give us an output of the opposite divided by the hypotenuse, a ratio of the opposite to the hypotenuse. So arcsine, which is the inverse of sine, is going to have an input of the opposite to the hypotenuse. So if we think of this fraction in that way, then we can think of x as being the opposite side of a triangle. We can think of 9 as being the hypotenuse. Now the overall output of this function, if the input is the opposite side, is going to be this ratio, and cotangent is the reciprocal of tangents. So instead of opposite over adjacent, our output is going to be adjacent over opposite. Adjacent over opposite. So first thing we want to do when we analyze this function is think about what are the limits on x? What's the biggest x can be and the smallest x can be? Well, the hypotenuse is 9, so that means the x can't be bigger than 9 because the hypotenuse is the longest side. And then we're going to cut x off at 0 for our purposes. We're saying that we're not going to deal with negative x values and just only deal with the positives because we're considering positive lengths. So x could be 0 or x could be 9. It could be anywhere from 0 to 9. So what we can do is think about what would happen if x was 0. What would that look like? Well, if we draw this triangle and with a reference angle, it's a right triangle with a reference angle, we're saying the opposite side's x and the hypotenuse is 9. So picture what happens when we let x go to 0. This length is going to get smaller and smaller and smaller and smaller, so we can draw that triangle where the hypotenuse is 9 and that opposite side gets smaller. So now this is 9. The adjacent side is becoming close to 9 as well because the opposite side is approaching a length of 0. So those two are almost the same length. So then if we think about the output, which is adjacent over opposite, well, the adjacent side is about 9 and the hypotenuse is about 0. And remember, if we divide by a small number, right, if we have cookies and we divide them into crumbs, we can share with infinite people. So what's happening is our adjacent over our opposite seems to be approaching infinity as we approach, as we let our x value approach 0. Now, if we let our x value approach its upper limit, which is 9, that triangle would look like this. So again, the hypotenuse is 9, the opposite side is about 9, and then that adjacent side is about 0. So that means we're going to have roughly 0 over roughly 9, which is going to be equal to 0. So that means that our A over our O must be approaching 0 as x approaches 9. And then this would be as x approaches 0. So that just needs to show up in our graph. So when we draw our graph, we know that we're going to be between 0 and 9. We know that as we approach 0, our output seems to be approaching infinity. And at 9, our output's going to be 0. So all we have to do is say that we have a point here at 9, 0, and then as x approaches 0, our output has to approach infinity. So this graph represents the ratio of an adjacent side to an opposite side as that opposite side goes from 0 to 9 with a hypotenuse of 9. That ratio will start really big, which is this triangle, but then as x gets bigger and bigger and bigger, that ratio is going to approach 0. Now, last thing is it says which one of the following is equivalent to the function, and it gives us a couple options. Well, that's going to be figured out by going back to this triangle and thinking about Pythagorean theorem. Let's just call this, we need to call it a variable. It's the adjacent side, so I'm going to call it capital A since my lowercase a's kind of look like 9. So we have our x squared plus our a squared is going to equal 9 squared. So then what's a squared? It's equal to 81 minus x squared. And then a is equal to the square root of 81 minus x squared. So then what we want to think about is, well, first of all, do not try to simplify this, because the square root of 81 minus x squared is not 9 minus x, because 81 minus x squared is actually 9 minus x times 9 plus x. So we can't just say that the square root of 81 minus x squared is 9 minus x, because that's not true. This is how this factors. So this is as simplified as we can get. So then we have to write our final version, our final output, which is going to be adjacent over opposite. So we just found our adjacent side to be square root 81 minus x squared. And our opposite side we already knew was x. So that ends up being the first function in that list of functions. All right, so this rational function actually represents this triangle situation where x is the opposite side. X can go from 0 to 9, and the output represents a ratio of an adjacent to an opposite side in a right triangle.